Everyone, welcome to the podcast. Brian Beeler here, and I'm with Luca in the CoolIT booth at Data Center World in DC. And this is the first time, I think, in a while we've tried to do one of these pods at an event. It's pretty quiet here, but I'll apologize in advance if you hear vacuum cleaners or other pre-expo opening noises. We're standing in front of your brand new CDU. You guys have launched this week. What's going on with this system?
Yeah, so fortunately this right here is our brand new CHx2000 liquid-to-liquid CDU. It is capable of 2 megawatts of heat rejection, so it is essentially our most powerful CDU that we offer in our broad portfolio today. And it's in one of the most compact form factors and footprints in the marketplace. So this is all stainless steel, 4-inch piping, Victaulic couplings, 750 millimeters by 1200, so it's a standard rack. Lots of accessibility on both the front and the back.
Right.
And we're quite proud of it. It's definitely stuffing more power into the same footprint and gives us, I think, an advantage over the competition.
And for anyone that's just listening, in the description in the show notes, we'll have a link to an article that Harold's put together on this new CDU, so you can see everything about it, get all the specs, and we'll have some nice photos of it as well. I mean, visually, I know you don't ship these with plexiglass on one side, but visually it's quite stunning. The amount of metal in here is incredible, and all the pumps and everything. What are the challenges with a CDU? I mean, you guys have been in the game for what, a decade plus at this point? Probably longer. I'm sure I'm shaving some time off.
Yeah, so I mean, we started with rack-based CDUs initially, so obviously
Right.
in the smaller form factor, the ones that would sit integrated into the factory racks. But yeah, with the row-based units here, I mean, essentially the problems are still the same in terms of the approach temperature. I think is a critical thing for us, is just really understanding and having a system that has like a high efficiency heat exchanger and really powerful pumps to be able to keep that approach temperature really low and ensure that you can cool effectively all of the units that are under its power and under its control.
So it's kind of interesting as we think about direct-to-chip liquid, right? NVIDIA is a big proponent of this now and has been driving this with their massive TDPs. Right. But Intel, AMD, everyone else is right in there as well as they continue to push these chips.
Yeah.
And it seems like liquid was a little fringy, maybe even just 2.5, 3 years ago. I mean, you were certainly doing it. It was big in HPC, but the enterprise wasn't there. With all these new NVL systems, though, there is no choice. And so organizations are going to have to get comfortable if they want these big GPU systems with liquid cooling of some form or another.
Right.
And of course, you guys are leading the way with this direct-to-chip. But talk a little bit, we're here at Data Center World. Like, what's the sense of the people here in terms of what their comfortable level is or comfortability is with liquid cooling?
Yeah, I mean, I would say like generally it's still relatively new.
Right.
I mean, in our space, obviously we've been doing it for some time. We were at the NVIDIA GTC show and we were actually showcasing a wall of some of our liquid cooling innovations going back from 2009. So some of those to just kind of show the progression of time. But in this particular environment, like with Data Center World, I think a lot of the questions that we're getting are more from people who are, as you've mentioned, kind of newer to the liquid cooling space. We definitely are getting a broad spectrum of questions. We had a session yesterday which talked a little bit about selecting the CDU. And so that was a session that was really designed to kind of give people an understanding of the things to look for and how to start entering and participating in this market that, as you've mentioned, is going to become more and more prevalent, right? So as AI becomes one of the dominant sort of compute use cases, it's all liquid cooled. And even on the enterprise and on the enterprise side of things, we're starting to see it as well. Certainly all the server OEMs are starting to create like liquid cooled CPU-based units as well, so that it's not exclusively AI. And so it's just kind of getting them up to speed with that and used to the differences between air and liquid in terms of the maintenance.
We retrofitted an R760 last year with some of your cold plates, and you guys sent us the little baby in-rack CDU, which is not how most people will deploy liquid cooling, but it's a fun starter actually. Yeah. And when we did that, we did nothing but liquid cool the CPUs, and I think we saved 200 watts of power while increasing the performance a couple points on those CPUs. That was one server. If you do that at a rack scale, even just compute, forgetting about GPUs entirely,
Right.
that's an amazing savings.
Yeah, absolutely. Yesterday, actually, I was fortunate enough to take in a session here at the show, which was, I think it was someone from the University of Chicago, if I remember right, and they were talking about their experience with, it was a two-phase solution, but it was the same sort of thing. I mean,
Right.
it was using liquid effectively to cool their servers and doing a power savings study against that. And I think the number that he came up with in his particular use case was 37% savings for the lab that they were
Okay.
testing in. So pretty substantial. So obviously there's a lot of, the environmental aspects of
Right.
it here, and all of those things that you've talked about in terms of like, the smaller performance improvements as well, just keeping the system happy. You don't have to run as many fans and all of that great stuff.
The fans is the big thing, right? Anytime we're talking about liquid cooling, it's got to be about reducing energy consumption
100%.
in that server. Most of that energy consumption, we think about it as being driven by the silicon, but the fans, like the 25, 30% in some data I've seen out of Lenovo and others,
Yeah.
is pretty wild in terms of what you can save when we pin those fans back, or in some cases remove them entirely.
Right, absolutely. And that's sort of the bread and butter. I mean, we've taken from the supercompute space where they have 100% fanless solutions,
Right.
obviously in those blades. And that's where we leveraged a lot of our expertise and history from inside the IT, now moving into the infrastructure and everything that kind of supports that.
It's always wild going into these labs that are heavily liquid cooled, how quiet they are and how cool they are, because you're dealing with the heat so much more efficiently. It feels kind of like cheating, right? I'm used to going into the lab and having the servers scream, especially all these one-use systems that are really popular in the HPC and AI spaces.
Right, and the challenge with obviously all of the flux. So as the load comes on,
Right.
the compute
Wow.
spools up. All of a sudden, yeah, it's I don't know. It takes a strong person to get used to that day in and day out, for sure.
I don't know, it's sort of a nerdy white noise, I think, for some of
Yeah.
us. It's funny because I just posted a social video last week where I was looking at something. I think one of the big SSDs from Solidigm, they've got these 122s now, which are insane. But I shot this little video about it, and some of the comments on Instagram is, "What's that noise?" And I'm like, "Wait, do people not know what a data center sounds like?" And they really don't. We're talking to so many young software designers, AI guys that have never even seen the systems that they're interacting with, which to me is pretty nuts to consider.
Yeah, you're right. And again, as all these racks move up in thermal design power and density, you're going to just get more and more need to reject that heat somewhere, right? And so if you were to power it with fans, I can't imagine, what the decibel rating would be
Oh
in
my
one
gosh,
of those.
it would be
ongoing.
wild.
So yeah.
It'd be wild. And with liquid, you're going to get better density out of your racks. And now the challenge is, as you introduce systems like this, we still have to get power to the racks. I mean, when we look at older data centers, and as we look at enterprises that are bringing these big systems in and trying to figure out how to manage that, what do you see your responsibility in terms of helping your customers kind of figure out how to optimize their racks? I mean, that might be a little outside of your core scope, but I mean, you guys are kind of leading the vanguard there.
Yeah, definitely. I mean, fundamentally, I think one of the things that liquid obviously does is reduce power consumption. And you'll always have that kind of trade-off, right, in terms of as densities and design power goes up and up and up, you want to find ways to minimize the use of that energy, right? So using it towards the heat rejection by air is obviously not as effective as efficient as liquid, and so you want to reduce the amount of energy you're actually using to offset and reject that heat. And so as those go up, we'll have that juxtaposition between the two.
Right.
But liquid is obviously one of the ways that allows you to do that, and is probably the most effective means that we have right now. So we continue to expect that to grow in dominance over the data center space as these power-hungry GPUs and CPUs continue to consume that energy, and anything that we can do to be a part of reducing the reliance on energy, because we certainly are going to have some power challenges over the next little while as all these data centers come online.
No doubt.
And we're trying to do our little part to help that out.
Yeah, half the guys in here are dealing with power delivery and all these challenges. And I think there's a 42-foot truck over there that's a giant generator and all sorts of things,
right, yeah.
trying to bring that power generation to these data centers. That's a massive challenge. And yeah, to your point, you're helping drive down some of that wattage by being more efficient in the way you're cooling it. When you think about fluids, though, you've mentioned that a couple times. I want to be clear about that. You guys are just using water in these systems for the most part.
Yeah, I mean, our systems don't use a refrigerant, so we use single-phase direct-to-chip cooling. It is a PG25, so propylene glycol, 25%
Okay.
solution, primarily water with propylene glycol for antibiocides and fungicides, et cetera.
Which is one thing that people don't consider. They just look at these loops, and if you think about a PC that might have a liquid loop on it, most of us don't really worry about growing little creatures or fungus in there. But the water's not perfect, and of course you've got to account for that.
Right, and you know, as the water heats up, I mean, it makes for an ideal environment for a host of these things, right? If you've ever looked inside your radiator in your car, for example, you'll see that, you know, as that over time, you can see bits of corrosion, and it'll reduce sort of like the ability for the water to transfer cleanly through there. And that is part of the reason as well that you would use, you know, your antifreeze in your vehicle. So we're leveraging the same types of solutions to do that, and obviously we're trying to ensure that the water has the proper chemistry and is clean to continue flowing through. The microchannels that sit in the cold plates are also very, very fine.
That's what I was going to say, right? Is we look at these 4-inch pipes and you think about, well, a little bit of green goo won't make any difference, but it's when you get to the cold plate where you lose the efficiency if those things start to get clogged up, right?
Absolutely, right. And so that's exactly what we're trying to prevent, and that's why all of these systems come with additional filtration. You know, we're down in 25 micron, and so we're really trying to make sure that we're maximizing the performance of the entire solution and the entire system, not just the CDUs, not just the cold plates, but really just keeping it optimized in a way that keeps the system happy and, you know, powering that compute.
You talked about single phase, and that's just liquid. It's not boiling, it's not doing anything. And just to be clear to the audience, there's also a 2-phase, which is another way to do this. You guys aren't in that business, or maybe you're evaluating it. What's the deal with 2-phase?
Yeah, so I mean, I think in our space, we are definitely the leaders in single-phase direct-to-chip cooling. That doesn't mean, however, that we haven't evaluated other technologies. You've been to the liquid lab, and so in our liquid lab, we actually we've been doing a lot of testing and validation on 2-phase for some time now. So we continue to keep abreast of all the sort of trends. We've actually published a paper, though, when you look at it at a holistic system standpoint, we've found that there's a lot of runway for single-phase direct-to-chip cooling still. I know there's some folks here at the show that have said some other things that might disagree with me, but from our engineering standpoint, we believe that there's still a lot of runway in that. And the 2-phase solution in the testing that we've done, hasn't inherently been sufficiently better that it makes sense to move to a refrigerant-based solution today. So not to say that we're not looking at it, just not today.
And immersion, I guess, is the other popular technique, right? That works for different people at different scales. What do you think about that?
I mean, again, obviously I'm biased, but I would say that the key thing for us is that, you know, immersion comes with obviously benefit, but a lot of downside and challenge. You know, the market today has started making a bit more of a bet towards like direct-to-chip cooling. I think NVIDIA has said that their roadmap is really geared around direct-to-chip for the foreseeable future, and so long as that's what the market is driving towards, that's where our focus will continue to be.
You talked about the headroom a little bit there in terms of what can be done. You guys announced a couple weeks ago, I think, too, a 4,000 watt plate. I mean, that's wild.
Right.
How I mean, just to ask a naive question, how does that even work to be able to offload that much heat in one plate?
Well, with a lot of really good engineering, right? You know, the reality is, again, like we've been in this space for some time, and so we've developed a lot of expertise around all the sort of tips and tricks to do this, and you know, it's effectively like ultimately it's still the thermal properties of copper are kind of like what we work with, right? But we have designed this as a prototype, really just kind of like, again, show that there is still capability within this in the right use cases. We created a thermal test vehicle, so basically a series of heaters to replicate like the size of basically like a B200 and an NVIDIA GPU chip. And so from that, we were able to kind of prove out that we still had the ability to reject heat to 4,000 watts or 4 kilowatts. So
well, it's an interesting challenge, though, that you face, because obviously you partner with all the big silicon guys, but at the same time, they announce things at a cadence that's pretty rapid and maybe before things are really shipping. So you guys have to be pretty nimble, I suppose, because you're designing all along the way, but things still change all the way up to the end.
Yeah, I mean, no different than any other business. We have our challenges, right? So as we progress further upstream, working with the silicon manufacturers, we do see that, their designs change, right? So we might be mid-flight and version 3 turns to version 4, turns to version 6 pretty quickly, right? So, I wouldn't say we struggle, we work alongside them to continue to do the same thing.
Right.
But it's the same challenges that everybody else has, so we're all on equal footing. And I think we're just trying to adapt to that insatiable sort of demand and speed that the AI market is really driving today.
So talk about a little bit about the buying process for this gear. I've seen your stuff come through, like Dell, for instance. I know they've been a partner of yours on the cold plates, manifolds, all that kind of stuff in the CDUs.
Right.
But for somebody that wants to consume a rack level CDU like this, are they going to you guys? Are they going to your partners? Kind of what's the motion there? And kind of also, can you talk a little bit about what the decision tree is? Like, how do I buy a CDU? I mean, it's outside the typical IT motion. So.
Right. Yeah, so one of the things that we do, I think, really well is we are an end-to-end solution. So we understand how cooling and heat rejection works inside with the cold plate, so inside the IT, all the way through to the infrastructure required to size and plan and properly scope out your needs from a CDU perspective. We typically sell most of our products direct to market. We do direct factory integration at the cold plate level with a lot of the OEMs. So we would sell direct to the OEMs. They would do that installation direct in one of their factories. And so the cold plates get integrated directly at the factory under an OEM warranty. But these types of units are typically bought directly from CoolIT. We have a professional service group that helps support kind of like the engineering, design, sizing, install, commissioning, preventative maintenance, et cetera. So we run the whole spectrum of everything that's required to support direct liquid cooling.
And when you bring in liquid for the first time into an organization, IT obviously has concerns over that. The facilities management has some concerns. What do data center administrators have to do to embrace this? Do they have a headcount that's dedicated to managing this? Does it fall under someone else's umbrella? Who manages this thing?
Typically, the CDUs, for example, would be more of the infrastructure people. So the folks at the data center are the ones that are typically making design decisions. Sometimes it comes in conjunction with, if you're a colo, depending on the clients and the customers, they may also have their sort of like required vendors. So each customer and each data center might have its own slightly different nuance to the way that they actually like manage and buy the equipment. But typically the CDUs and everything done inside the facility and that infrastructure is done by the facilities people. So the data center folks themselves directly are the ones doing a lot of the purchasing and maintenance, et cetera.
So when you consider the fact that you could pair systems with your cold plates with CDUs that are yours or a competitor's conceivably, right? What's the industry done in terms of standardization? Because I've been in a lot of labs and seen manifolds that connect us to servers and AI systems that aren't the same as manifolds in other places. And are we at the point where you can deliver out of any CDU to any manifold, or kind of what's going on there?
Yeah, I mean, I would say there's a pretty substantial push to try to have interoperability.
Yeah, OCP's got a working group for liquid storage or liquid cooling, right?
Yeah, I would say OCP has actually been the leader in terms of trying to bring together a common standard and a common framework. And I think as a participant, as a vendor in that space, like obviously we have our own preferred ways. There are some challenges that I think we haven't quite solved in terms of when it comes to interoperability, in terms of warranty, for example, right? So how do you determine what component or piece is at fault if there's some kind of warranty claim, or how can you ensure that all the wetted materials are compatible with each other, because we all use a slightly different sort of secret recipe for the way that we design our products. And so I don't think that has quite landed yet, but I think definitely we're starting to see more involvement from groups like OCP, from the large OEMs and the manufacturers of the silicon themselves, also getting more involved in determining what's required to support them.
Well, it's got to get universal, right? Because I can't be dropping in servers from one vendor and then servers from another vendor, go to the manifold and be like, yo, these don't plug in. Like that's got to get better.
Yeah, I would think so. I mean, we're all looking forward towards a day where that's the case.
Well, it's in your best interest, right? I could see why, if you're an infrastructure company in IT, where you may have wanted to put up a little wall around your investments in liquid cooling, but at this point, I mean, being open, I think, is the right way to go.
Yeah, again, we want to be a participant and a leader
Sure.
and just have a voice in some of those decisions that are being made, because we do think we have an experience set that's able to contribute to that conversation. And so long as the decisions are being made, we think are beneficial for the industry as a whole, we're all on board with that. And so we'll see a drive towards more standardization, I would expect, in the near future, or sort of the immediate term here.
So what are the challenges going forward? You've got this massive new CDU, but what are you guys looking at a year, 2, 3 years out at a high level? What are the challenges going to be?
Yeah, I think the same challenges we've been trying to solve over the last little while, right?
Just hotter and hotter?
Amplified. Yeah, just hotter and hotter. I mean, I think, in the cooling space, I think the challenges remain the same. Like thermal management of these incredibly dense, hot 1400, 1600, 2000 watt unit systems. And so that is, I don't think that's going to change. I think that's actually the same problems we're going to have to solve. I don't think we've run up against the constraints of, material science or engineering yet. There's a lot of people that have a lot of great ideas. I think we'll start to see more of maybe a mix of different types of technologies being used to try to achieve those kinds of results. I think the bigger issue is still on the power side.
Right.
So, I'm glad that we operate on the cooling side, because I think the first thing that will stare us in the face is the power aspects. But yeah, we're working really hard to continue to support that ecosystem and, do the things that we've done for the last 24 years.
What can we do operationally to advance liquid cooling, whether it's smart leak detection or reduce flow to a system that could be compromised, and be able to communicate? Because that's one of the things, right, is if we look at a server, for instance, that has out-of-band management, I can shut it down if I want to.
Right.
If I could detect some sort of leakage or something and have some actions take place. Is that kind of stuff progressing?
Definitely. So in our advanced technologies group, we are evaluating a series of technologies to try to have smart sensors and smart leak detection. We've had some customers ask us for different things about, how could we isolate specific problem areas, et cetera. And I think you'll see that across the entire system. As we start seeing that, we're starting to see more demand for redundant sensors, and maybe even AI can actually come in and start supporting some of that calculation and evaluation. But we're definitely looking at getting more targeted in terms of making sure that the impacts, especially when these systems run on really large loops of clusters of technology, to try to isolate those problems into smaller areas that can be problem solved and repaired quickly if there is an issue.
All right. Well, clearly, I mean, looking around the show floor here, this is a big concern. The liquid loops, the CDUs, the cooling, the power, all this is really important. And as the show floor sort of starts to open up and gets louder, I just heard my first vacuum. I think we're going to stop now before we risk losing all of the audio quality. But like I said, I've got links in the description here, and we'll have a little bit up on storageview.com if you want to learn more about the CDU, the 4,000 watt cold plate, and all the innovation that CoolIT is driving. Thanks for doing this. Appreciate it.
Thanks.